Hey guys, welcome back. This is an interesting lesson because we're going to look at some very interesting concepts. We are going to talk about ordering records in a dataset. You're probably thinking, what is so special about ordering? If you want to order the records in the stocks dataset by closing price in descending order, we can write a simple query like this. Select star from stocks, order by price underscore close descending, correct? Yes, but this simple order by statement has some performance implication. Please pay very close attention to this lesson because whenever we are asking Hive questions in an interview, we always touch on this topic because quite frankly, there are so many good questions from this topic. Let's now execute this query in our cluster. We already have the stocks table, so let's execute the query right away. The first thing you will notice is number of reduced tasks determined at compile time equals 1. Why Hive is choosing to run the order by statement with just one reducer? Because order by does a global ordering of all your records in the dataset, which means to do a global ordering, all the records in your dataset must be sent to one reduce. This is a serious problem. If you have a very large dataset and when all the records in your dataset are sent to one reduce, this will lead to memory issues and the execution time of this reducer could be off the charts. So what is the solution? The solution is to use multiple reducers instead of just one. But how to do that? Let's wait for this execution to complete and we'll see how we can set the number of reducers to more than one. Here's the output of the stocks dataset ordered by the closing price column in descending order. Now we will see how to set the number of reducers to more than one. You can set the number of reducers that you would like to use using the property map_reduce.job.reduce in your Hive session. So let's use the property and set the number of reducers to 3. Copy this and let's execute in our cluster. Now we have set the number of reducers to 3. Let's run the order by query again and see what happens. Again, we are seeing that the number of reduced tasks is set to 1. Since the order by does global ordering of your dataset, the number of reducers will be always forced to 1, even when you specify you want to run with more than one reducer. So what is the real solution here? The answer is sort by. When you use sort by, it uses multiple reducers. Let's look at this query. For simplicity, we are filtering only records from year 2003. And we are sorting the records by symbol in ascending order and closing price in descending order. Let's execute this command and let's review the results. To review the results from this query execution, I'm storing the results of the query in the local file system using the insert command. So we are saying insert overwrite local directory and we are giving the location in the local file system. And we're also saying the output has to be delimited by comma. Now the output of this select statement will be written into this directory delimited by comma. Before we execute this query, let's set the number of reducers to 3. So now the number of reducers is set to 3. Now let's copy this query and execute this in our cluster. There you go. As you can see, the number of reducers is now set to 3. Let's wait for the job to complete and then let's review the result. The job is now complete and the output of this job is now copied to the local directory right here. So now let's go to the local directory and review the output. We see 3 files here, one for each reducer. Let's open file number 1. As you can see, the records in this file are now sorted by symbol first in ascending order and then sorted by closing price in descending order. But there is a problem. Let's pick a symbol. For example, let's pick B3B. We see records for B3B in this file. Now let's open the second file. Let's look for records from symbol B3B. Even in this file, we see the records are sorted by symbol first in ascending order and then sorted by closing price in descending order. But the problem is you will see the symbols from the first file also appearing in the second file. For example, the symbol B3B is also in the first file and also in the second file. And you'll observe the same in the third file as well. They're not duplicates. It is just that the records for the same symbol are distributed between the reducers and then sorted in each reducer. That is not ideal. Because for true logical ordering, we want all the records from the same symbol to go to the same reducer and end up in one file. So how do we make all the records from the same symbol go to the same reducer and finally end up in the same file? The answer to that is we can use distribute by along with sort by. In the distribute by class, specify the column that should be treated as the key for the reducers. In our case, we would like all the records for the same symbol to go to the same reducer. So we will specify the symbol column in distribute by. Let's run this query now. Again, we are sending the output to a local directory and we are saving the output using comma as the delimiter. So let's copy this and execute in our cluster. Now again, as you can see, the number of reducers is set to 3, which is perfect. Now let's wait for this job to complete, and after that we'll review the output. Now you may also notice since we are using 3 reducers as opposed to just 1, our job is completing much faster. Now that the job is complete, let's go ahead and review the output. Now let's go to the output location and there you can see 3 files again. So let's open the first file. If you see the output, you can see the records in the file are now sorted by symbol in ascending order and then sorted by closing price in descending order. Exactly what is expected. But let's just make sure that each symbol is written into only one file. So let's pick up a symbol. Let's pick up the same symbol that we used before, B3B, and make sure that the records for symbol B3B is only present in one file. So let's check in this file first, B3B. So the records for B3B is present in file number 1. Now let's go to file number 2 and file number 3 and see whether we see records for B3B. Technically, we should not see records for B3B in any other file since it is already present in file number 1 because we use distribute by along with sort by. So let's go and check the second file. Now let's look for the records from symbol B3B. So no pattern found. There are no records for symbol B3B in file number 2. Let's go ahead and look up file number 3. B3B. Again, there are no records for symbol B3B in file number 3 as well. This is perfect. Now the records are not only sorted properly, we also do not see overlapping results between files. One last thing. If you have the same set of columns in sort by and distribute by, and you're sorting the records in ascending order, you can replace sort by and distribute by with cluster by. So if you look at this query in which you have distribute by symbol, sort by symbol, you can replace both sort by and distribute by with cluster by. Both two queries are essentially the same and will give the same output. So to summarize, order by does global ordering and will always use one reducer, which is problematic because it will lead to performance problems. We can use sort by along with distribute by to use multiple reducers and send records from a certain key column to the same reducer. Finally, cluster by can be used when the same set of columns are used in sort by and distribute by. With that, let's wrap this lesson. See you in the next lesson.